Hello my schoolers, you are welcome to my school channel. We'll be tackling the 2019 JAMB past question for physics. So, in this clip, we'll be solving questions number 61 to number 80. I'll be providing with step-by-step explanation to each of these questions. So always remember to check the description below for the links to other video clips that provide these solutions. So join me as we solve question number 61. Any line or section taken through an advancing wave in which all the particles are in the same phase is called what? This is definitely the definition for wavefront, because wavefront talks about either the maximum disturbance or the minimum, which is the crest and the trough. Okay, so once you know the definition of each of the parameters or the terms stated here, you will just select that option D as this definition. So option D is correct. Question number 62. You can see this diagram. I'm very sure that some of you are very familiar with this. Okay, in which of the points labeled A, B, C, D, and E on the conductor shown would electric charge tend to concentrate the most? So just know this as a matter of simple rule or relation, that electricity would, or electric charge will be concentrated at the pointed end, okay, at the most pointed end, and places with high density, the outermost part of this kind of hollow conductor. Okay, so the correct answer is point E. So which of our options has point E? That is option D. Question 63. The point at which the molecules of a loaded wire begin to slide across each other, resulting in a rapid increase in extension. Take note of this, rapid increase in extension due to the loaded wire, the wire being loaded. So definitely you should recall that elastic limit is that extension that is produced. I just want to give you a summary whereby when you extend a particular material, okay, it's going to get extended, but it regains its original shape. For instance, your rubber band, you can pull it apart to an extent. Once you release the force or you remove the load, it comes back to its original shape. That is elastic limit. So any point beyond that elastic limit, you realize that the rubber does not come back to its original shape, okay? And any increase in load will also cause a large extension, okay, in the size of the material. So this definition fits yield point. So yield point is that point whereby the material becomes plastic, okay? It doesn't go back to its original shape. And again, a small increase in load will cause a large extension or a rapid increase in extension. So option A is very correct. By now, I know many of you have downloaded our Myschool mobile app or purchased our Myschool software. But if you haven't gotten yours, to help you in your preparations for coming exams, please just click on the link in the description below that will take you to the Myschool website so you can download the Myschool mobile app or the Myschool software to enhance your performance in your coming exams. So join me as we tackle question number 64. So we have this diagram, okay? These are units for capacitance. So the resultant capacitance in the figure above is what? So take note of this. This is an arrangement, this, and this is an arrangement in series. Okay, this is an arrangement in parallel. Okay, so we can bring this together, okay, to make it form a series. So that will be 2 plus 4. That gives you 6. So we are going to have 2, okay, 3, 6, and then 4. So now let's solve out the solutions for this question. So remember that capacitance in series, this is an arrangement in series, will be 1 over the total capacitance, okay? 1 over the first capacitance, which is 2 from our question, plus the next, which is 3, okay? From the next, remember they were in parallel, we brought them together to be in series, that is 1/6 plus the last one, which is 1/4. So the LCM here will be 12. 2 in 12, that is 6 times 1, 6, okay. 3 in 12, that is 4 times 1, that gives you 4. 6 in 12, that is 2, 2 times 1, that is 2, okay. So 4 in 12, that is 3, 3 times 1 gives you 3, equals 1 over, or the inverse of the capacitance, okay. So we have 1 over C total, the capacitance, the total capacitance, okay, equals 6 plus 4, that is 10, plus 2, 12, plus 3, that is 15. Okay, 3 here 4, okay, 3 here 5. So once we cross multiply, we would have CT times 5 equals 4 times 1. So what do? Divide both sides by 5. So we are going to have our total capacitance equals 4 times 1, that is 4 over 5. Or if you want to bring it to decimal, that is 0.8. Okay, we have the microfarad. So let's go through our options together. So option B is very correct. So I know you are enjoying this sort of content and you want me to bring you more of them. So don't forget to hit the like button, click on the subscribe button and tap on bell notifications so you can always be in touch as we release the next videos. So we have question number 65. The lower fixed part of a faulty thermometer reads 2 degrees Celsius while the upper fixed point is 100 degrees Celsius, okay? What is the true temperature when the thermometer reads 51 degrees Celsius? So this is very, very easy. So you recall this diagram. Okay, the upper fixed point, the lower fixed point, and what have you. So I'm not going to bother you with this. I'm just going to take you straight ahead to the solution. So just remember that the reading, which we have the reading at 51 degrees Celsius minus the lower fixed point of the thermometer that was read, which is 2, okay, over the upper fixed point, which is 100, like we know, minus this reading, which is still 2, okay, equals what we are asked to get. So what is the true temperature, which we are looking for, over 100. That is the scale for the thermometer. So now let's do this. So we have 51 minus 2, that gives you 49, over 100 minus 2, that gives you 98, okay, equals theta over 100. So once we multiply, we are going to have 49 times 100 over 98 equals theta. So the true temperature we are looking at, or we are looking for, is 50 degrees. When you divide this, all of this together, you get 50 degrees. So let's go through our options together. Okay, option B is correct. So we have question number 66. If a body moves with a constant speed and at the same time undergoes an acceleration, its motion is said to be what? Circular motion, because the centripetal acceleration is directed towards the center, okay, and there is a change in the velocity constantly, okay. So that is definitely a circular motion. Option A is very correct. Question number 67. A coil X is moved quickly away from the end Y of a stationary metal bar, and the current then flows in X as shown above. Then what is point Y? Okay, so at first you should be able to determine alongside with me that this is definitely a magnetic bar, okay, of North Pole and South Pole. And if you are going to introduce Lenz's law of electromagnetic induction, okay, which says that the induced EMF opposes change in the magnetic flux, that is, from the north pole, it's going to recede the coil. So the coil moving away from the bar, or the north pole of the bar receding the coil, indicates that Y is the north pole. So option B is correct. Just remember that several solution providers are waiting for you on the Myschool website to ask your questions right now. So with the link I have provided you in the description below, you can ask those questions on the spot. So join me as we tackle question number 68. A boy pushes a 500 kg box along a floor with a force of 2000 Newton. If the velocity of the box is uniform, okay, the coefficient of friction between the box and the floor is what? So that's very easy to solve. So recall that we have weights of the box is mass times acceleration due to gravity, okay, where the mass is 500 times acceleration due to gravity, that is 10, so that gives you 5000 Newton. Okay, the force, the frictional force, okay, as 2000 Newton. Okay, so we are asked to find the coefficient of friction, which is called mu. All right, and that is what we are looking for. That's okay. Then the normal force, we are given the normal force as this, okay, 5000 Newton. So just pick it up that mu, okay, equals, when you divide it, the frictional force over the normal force. Okay, so we have a frictional force as 2000, okay, over the normal force, which is mass times gravity, as 5000. So a 0 strikes out 0. 2 divides 5 equals 0.4. There are no units because this is in Newton, this is in Newton. So Newton strikes out Newton, so there are no units. Okay? There's no units for coefficient of friction. So when we go through our options, we see that option D is very correct. So as we follow along each of these videos, perhaps you have one or two explanations that you think can improve this content, or that you think can better explain any of the questions so far. Please, I would like to know in the comment section below by indicating the number and the solutions you would like to recommend. Join me as we tackle question number 69. The following are some units, okay? This is Newton per seconds, this is none, this is Newton per meter square, this is joules per kilo, okay, this is joules per kilogram, okay? So what are the units of latent heat? So just recall that latent heat is the heat energy released or absorbed during a phase change per mass. So if you want to pull this out mathematically, you will say the specific latent heat, L equals Q, that is quantity of heat energy, over mass M. So where the unit of Q, which is heat energy, that is joules, okay, over or per the mass in kilogram. So the units for latent heat will be joules per kilogram, okay? So that is V only. And which of the options has V? That is option D is correct. So question number 70. When two objects A and B are supplied with the same quantity of heat, the temperature change in A is obtained to be twice that of B. The mass of A is half that of B. The ratio of the specific heat capacity of A to B is what? So this is very, very easy to solve, okay? So remember that you can take quantity of heat equals MC delta theta, okay, where the C stands for the specific heat capacity, okay. So I can just have it like this: Q equals mc theta, which theta stands for the change in temperature, okay. So this is for A. This is the formula we're using for A and B, okay. So for A, I would have Q equals mc theta, all right. Then for B, I will also have Q equals mc theta. So now let's use the parameters we are given in our questions, the values we have, to solve this question. So we have two objects, A and B, okay, supplied with the same quantity of heat. So that means the same quantity of heat were supplied to A and B. So if there is 1 joule of heat here, definitely there is 1 joule of heat here. So this is already gone. Okay, so to make our work meter, I can remove this. Okay, that's correct, right? So from the question again, we are now told the temperature change in A, okay, this in A is obtained to be twice that of B. So temperature change in A is seen to be 2 times of this, 2 times of the temperature of B. Okay, so to make it more neater, I can bring it here, 2, isn't it? Okay, so we've gotten that value. Then we move on. We now have A, the mass of A is half that of B. So the mass M of A, okay, is half that of B. So the mass of A is half that of B. Okay, so already that will be 2, strikes out 2. So that means we have MC theta, MC theta. So already the mass is gone. Okay, theta is gone. Then we now see that the specific heat capacity of A equals the specific heat capacity of B. So seeing A ratio B will give you A over B. So specific heat capacity of A is 1 over specific heat capacity of B is 1. So A ratio B is actually 1:1. So let's go through our options. Option C is correct. Question 71. The volume of 0.354 grams of helium at 273 degrees Celsius and 114, okay, this is for pressure, of mercury pressure is 267 centimeter cube. So don't get confused. This is the pressure and this is the volume, okay? Calculate the volume of, so this is very easy to tackle. We are just going to use the ideal gas equation, which is P1 V1 over T1 equals to P2 V2 over T2. So we are asked to find V2. So let's make V2 the subject of formula. So once you cross multiply, you will have this come here. So we have P1 V1 times T2, okay, equals, if we are asked to make this subject of formula, that means we have T1 coming here, divide both sides by T1 P2, okay, so this will be the formula for V2 that we are asked to find. So let's go through our parameters once again. So we have helium at 273 degrees Celsius. So T1 equals 273 degrees Celsius. If you are bringing it to Kelvin, that is plus 273, okay? So that should give you 273, 3 plus 3, that is 6. Okay, 7 plus 7, that is 14. You write 4, then you carry 1. 1 plus 2, 3 plus 2, 5. Okay, in Kelvin. Okay, so remember this is at standard temperature and pressure. So T2 would definitely be equals to 273 Kelvin as standard temperature and pressure. So P1 is given as 114. P2 at STP is, remember this is tapped at STP, so P2 will be 76. So it ought to be 760, okay, but we are operating our values at CCHG instead of mmHg, okay, that's why we have 76. Then from the question, V1 has the value of 2667. Of course, we are looking for V2. So let's slot in our values into the equation we have here. So we'll have P1 as 144 multiplies V1, which is 2667, okay, multiplies T2, which is 273, over T1, which is 546, multiplies, okay, P2, which is giving us 76. So by the time we divide, after we multiply these values, we multiply this, by the time we divide it, just to save time, okay, we should arrive at 2000.25. Remember volume in cm cube. So volume 2 equals this. So let's scan through our options. Definitely option A is correct. Question number 72. Which of these is observed when air is pumped out of a discharge tube without lowering its pressure? So at first, you will recall that in a discharge tube, the pressure has to be low and the voltage has to be high. So air can only become good conductor of electricity at low pressure and high voltage. So if you don't reduce pressure, the air cannot conduct electricity. So option C is correct. Conduction does not occur. Question 73. Which of the following characteristics of a wave is used in the measurement of the depth of the sea? So they actually do that by echo, or you can refer to it as sonar, that is sound navigation and ranging. What they just do is, because of the shallowness or the depth of different parts of the sea, they send out a pulse of sound energy into the depth of the sea. So how fast the sound travels back, that's the echo, the reflection of the sound back to them, will tell the depth of that particular part of the sea. So option D is correct. As you follow through each of these videos, it is very important that you practice and test yourself using the Myschool tools that we have provided just for you. So with the link I have provided in the description below, you can purchase the Myschool mobile app or the Myschool software so that you can gain confidence and competence towards your coming exams. So join me as we tackle question number 74. If the attraction of the sun is suddenly ceased, wow, the earth will continue to move in a straight line, making a tangent with the original orbit. This statement is derived from, we will call Newton's first law of motion, says that a body will remain at rest or continue to move in a straight line unless it's been acted upon by an external force. So moving in a straight line, that is Newton's first law of motion or inertia. Option A is correct. So don't forget to hit the like button, click on the subscribe button and tap on bell notifications so you can get informed as we release the next videos. Question 75. Heat may be transferred by conduction, convection and radiation. By which of these methods does heat travel through vacuum? So that is true as electromagnetic waves, okay, and that can travel through a vacuum, and that's definitely radiation, the radiation of heat from the sun. Okay, so option C, radiation only. Conduction requires a material medium, convention requires a material medium. So radiation, it emits electromagnetic waves just like the sun, like I mentioned earlier, and can travel through a vacuum from space down to the earth. So option C is correct, radiation only. Question 76. The part of the human eye that does similar work as the diaphragm of a camera lens is the what? It is the iris that controls the pupil. That means the amount of light that enters into the eye. So the same function the diaphragm does in the camera. So iris is very correct, option C. Question number 77. A projectile of mass 4 kg is fired vertically and reaches a maximum height of 40 meters. Calculate the potential energy at the highest point. So this is very easy to solve. Recall that potential energy, PE, equals mass times gravity times height. Okay, the mass is given as 4 kg times acceleration due to gravity is 9.8, but we can approximate to 10, okay, times the height, 40 meters. So 4 times 10, 40, 40 times 40, that will give you 1,600. Potential energy measured in joules. So which of our options confirms our answer? Option B. Remember that several solution providers are waiting just for you to ask your questions on the Myschool website. So with the link I've provided you in the description below, you can ask those questions right now. Join me as we tackle question number 78. The length of the second hand of laboratory clock is 0.1 meter. Calculate the speed at the top of the second hand. So recall that the clock, the laboratory clock, is 360 degrees, okay? Circle. And bringing 360 degrees to radians, that gives you 2 pi radian. Isn't it? Okay, so, and you remember that angular speed is cos to theta, and theta in this case talks about the second hand that reads 60 seconds, okay, 1 second, 2 seconds, 3 seconds, 4 seconds, up to 60. So whatever theta we'll be having will be 2 pi rad, okay, over the 60 seconds that it reads, okay. So that is 2 pi rad over 60. Very well. So we are asked to look for the speed of the second hand. Remember that linear speed equals this, angular speed times the radius. From the question, we have the length of the second hand of laboratory clock is 0.1. So that makes the radius. So the radius here is 0.1. So we would have where our W equals to theta, the angular speed equals to theta, and theta is 2 pi rad over 60. So that would be 2 pi, okay, over 60 times 0.1, which still means 1 over 10. Okay, so 2 here 1, 2 here 30. So on the numerator we have 1 times pi, that is pi. Pi times 1, that is still pi. So, and we know that the value of pi is 3.142 over 30 times 10, that gives you 300. Okay, so on dividing this, we should have the value 0.0104733 and what have you. So if we are to bring our answer to standard form, okay, just move 1, 2. Okay, so that will be 1 point, when I approximate this, it becomes 5, 1.05 times 10 raised to power minus 2. So join me as we go through our options together. So option A is correct. So remember that the unit is for linear speed, that is meters per second. Okay, so option A is very correct. So, going through each of the questions and the explanations, if at any point you see one or two suggestions that you can make or recommendations that you'd like to share, please, I'd like to know in the comment section below. Indicate the question number and the recommendations you'd like to share with me. Question 79. Work done on an object to bring it to a certain point in space is called what? So just record the definition of GPE, gravitational potential energy, is that energy because of an object position above or its height to the Earth's surface, away from the Earth's surface. So when you talk about something above the Earth's surface or the height above Earth's surface, you're talking about space, okay? And that makes the option A, gravitational potential energy, correct. Down to question number 80. A copper rod 5 meters long when heated through 10 degrees Celsius expands by 1 millimeter. Okay, if a second copper rod 2.5 meters long is heated through 5 degrees Celsius, by how much will it expand? So we are looking for the linear expansivity. And when you take note of our options, you realize that the units are given in millimeters. So you don't really need to do any conversion. So at first, take note of the first copper rod. For the first copper rod, you will notice that it was 5 meters long and it expands to 1 millimeter. Okay? 1 millimeter at a temperature of 20. Just take note of this. The second copper rod that was 2.5 meters, we are asked to find by what length, but by how much will it expand for accuracy, okay? And at a temperature of 5 degrees. So just take note of this. You can see that the temperature difference, if you divide it, 5 year 1, 5 year 4, okay? That shows you that the second temperature of the second copper rod is 4 times lesser than the first one. So whatever answer we'll be getting from here, we'll divide it by this 4. Okay? So if you cross multiply, recall that this is the way we derive this. 5 meter rod expands by 1 millimeter. 2.5 meter rod expand by how much? And that is the x that we have here. Okay? So when we cross multiply, we would have 5 times x equals 2.5 times 1. Alright, so what do? We divide both sides by 5. This 2.5 still means 5 over 2. Right? Okay, so we have 5 times x equals 5 times 2 times 1 still gives you 5 over 2. Dividing both sides, okay, divided by 5. Isn't it? So we'd have x equals 5 over 2 times 1 over 5. 1 times 1, we have 1, okay, over 2 times 1, we have 2. Alright, so we said whatever answer that we get, we have to divide it by 4, because the temperature difference between the first copper and the second copper is 4, okay? 5 times 5 times 4 to give you 20. So this answer, we're going to divide it by 4. So that means 1 over 2 times 1 over 4, okay? And that gives you 1 over 8. If you divide 1 by 8, you would have 0.25. Remember, we are asked to look for the expansivity in millimeters. Okay, so your answer is 0.25 millimeters. Option B is correct. So, don't forget that this same method, you can use the formula linear expansivity equals the change in length, okay, original length times change in temperature. Okay, for the first copper rod, which will also be equals to that of the second copper rod, All right, so you can use this formula to tackle this question, but I'm just introducing something that is far easier and quicker to solve by. Okay, so you should still arrive at the same answer, 0.25. So, dear scholars, that is all for this segment, but you know that there is still more to come. I strongly believe that you are enjoying this sort of content and you'd like me to bring you more. So don't forget to hit the like button, click on the subscribe button and tap on bell notifications so you can get informed as we release the next videos for you.